In section 1.3, we're going to look at various types of sampling techniques. A census is a count of the entire population. So when you're actually able to go out and get information from the entire population, that's when we can have conducted a census. Generally speaking, censuses tend to be very difficult and expensive to perform, and samples oftentimes are just as reliable and are much more efficient and time-saving. A sample is simply a count or a measure of a part or subset of the population. One of the gold standards in terms of types of sampling is what's referred to as a random sample or a simple random sample. This is when each member of the population has an equal chance of being selected. For example, if we had, let's say, 100 students or 100 people in a room, you could assign each individual a number from 1 through 100, and then using either a random number generator or like a lottery style ball machine, you could pick out however many random numbers you would want to generate your sample size, and then if somebody's number came up or they were the number was chosen, then they would be a part of the study. So generally, one of the things that's nice about simple random samples is because each member has an equally likely chance of being selected, it totally eliminates bias and is a really kind of reliable type of result. We will not in our class be generating random samples, but just be aware that there are really a lot of different ways you can do this. There are some table style approaches that kind of allow us to generate random samples. More popularly though, technology is used. For example, the TI-83 and 84 has a random integer between command where you just tell the calculator, I want so many numbers between this number and a second number, and it will generate them for you. Excel is also fantastic at this. There's a random function command in Excel, as well as I believe there's a bunch of different apps online that you can use to generate a list of random numbers should you want to do so. But the thing to take away from this is when we talk about a simple random sample, every member of the population has an equally likely chance of being selected. Oftentimes when we do our sampling, it's important to determine whether we want to do it with or without replacement. When sampling is done with replacement, it's possible for one member of the population to be selected more than once. Alternatively, if sampling is done without replacement, then whenever a member is chosen for the sample, their name is then removed from the list, and they would not be able to be selected a second time. Some other types of methods include stratified sampling. Stratified sampling is used when it is important for the sample to have members from each segment of the population. This gives each different unique group an opportunity to participate. Depending upon the focus of the study, members of the population are divided into 2 or more groups called strata that share similar characteristics. It could be anything ranging from age, gender, ethnicity, political affiliation, etc. And then a sample is then randomly selected from each strata. Using a stratified sample ensures that each segment of the population is represented. We have a cluster sample, and a cluster sample is conducted when the population falls into naturally occurring subgroups, each having similar characteristics. A cluster sample may be the most appropriate sampling method in that setup. To select a cluster sample, we divide the population into these groups called clusters and select all members in one or more, but not all of the clusters. Examples of clusters could be different sections of the same course, different branches of the same bank, or if you want to partition or break a state up, you can look at the different counties would constitute a cluster sample for a state. A lot of students, and it's understandably so, will kind of confuse stratified with cluster sampling. In both of them, they share some common characteristics, but with one huge fundamental difference. So in either case, you're kind of breaking the population up into subgroups. In stratified sampling, what we're doing is you break the population into groups or strata, and then from each strata, you select some people. So all groups are represented, and you pick some from all. In cluster sampling, the quantifiers are switched. In a cluster sampling, we choose some clusters, but then you choose all members from that cluster. The next type is systematic sampling. This is a sample in which each member of the population is assigned a number. The members of the population are ordered in some way, starting with a number that is randomly selected, and then sample members are selected at regular intervals from that number. For example, choosing maybe every third person, every fifth person, every 100th person, etc. Or even if you have like a formula that generated your sample numbers, this is a systematic sampling style. The last type we're going to look at, which is one that should be avoided, is convenient sampling. This is a sample that consists only of available convenient to use members of the population. These types of samples often lead to biased results. So with convenient samples, they're kind of nice in the fact that they can readily get us a lot of data really quickly, but they tend to be very unreliable because values that are convenient tend to have a lot of shared common characteristics that might not be generalizable to the larger population. In terms of data collection, we have a bunch of different ways in which data can be collected. The first is an observational study. This is where a researcher observes and measures characteristics of interest of a part of the population, but does not change existing conditions. So in an observational study, the researcher is just kind of sitting back, letting things unfold as they would naturally occur, and taking notes and doing measurements. In an experiment, we have a treatment that is applied to part of a population, and the responses are observed. Another part of the population may be used as what's called a control group, in which no treatment is applied, and in many cases, especially in medical research, we have yet a third group, which is called a placebo group. It could be the third group or a second group, but in a placebo group, they receive kind of like a fake or artificial treatment that is supposed to get people to think that they're receiving the treatment, when in fact, oftentimes it's something called like a sugar pill, or has like no effect whatsoever. And then at the very end, what people would do as experimenters, they would compare their experimental or treatment group to the control group to see if there's any differences between the two groups. A simulation is the use of a mathematical or physical model to reproduce the conditions of a situation or a process. Collecting this data often involves the use of a computer. The simulations allow us to study situations that are impractical or even dangerous to create in real life, and oftentimes save time and money. And then lastly, we have the classic survey. This is an investigation of one or more characteristics of a population. Surveys oftentimes can be carried out through the mail, via interview, telephone, internet, social media polls, etc. In designing the survey, it's important to word questions so that they do not lead to biased results. Let's take a look at the following situations and determine which method of data collection will be best served for each situation. If we were to study the effects of changing flight patterns on the number of airplane accidents, that should be done via a simulation. So before we make any changes to see if less planes would crash, we would want to first run a simulation to see what the output of that simulation would tell us. For a study on the effect of eating oatmeal on lowering blood pressure, that would be an experiment. The treatment in this study would be the actual process of eating the oatmeal. We'd have probably one group of individuals with blood pressure, a second group, a control group, that would have a similar blood pressure. One group would eat oatmeal, the second group would just carry on with their normal diet, and at the very end we would want to see, did the group that ate the oatmeal have a lower overall blood pressure than the group that didn't? So this is a experiment. If we wanted to study how fourth graders solve puzzles, this would be observational. And a study of U.S. residents' approval rating on the U.S. president, that could be done via a survey.